Hi everybody, here we're going to take a look at the vector addition, and here this is going to build up from what we discussed about vector components. So here we see two vectors. In a first vector, its length is 9.4 units and its angle is directed at 32 degrees from the positive x-axis. And vector 2, its length is 10.4 degrees and is directed at 73.3 degrees relative to the positive x-axis. And let's look at their components again here. So looking at their components, so let's see for the first vector here, to get it, so its x component is 8 and its y component is 5, so 8 units in the x direction, so 1, 2, 3, 4, 5, 6, 7, 8, and its y component should be 5, so 1, 2, 3, 4, 5. And remember that you get the components by taking, in this case, for vector 1, 9.4 multiplied by the cosine of 32 should give you 8, and 9.4 multiplied by the sine of 32 should give you 5. And similarly for vector 2, its x component is 3 units, so that should be 1, 2, 3, and its y component is 10 units, so each of these big squares here is 5, so 5 plus 5 gives you 10. So those are the components of the individual vectors. So this is what we looked at before. So now let's also take a look at how you add vectors together. So now let me just get rid of some of the terms here. So let's say that we have these two vectors, and let's say that we want to add them. So the way that you add vectors graphically is, I'm just going to put this vector here for convenience. So the way that you add two vectors graphically is that you take one vector, you leave it where it is, and you take the second vector. You can grab the vector by the tail and just move it while keeping the length and direction the same, and place the tail of the second vector onto the tip of the first vector. And so now let's see what the sum looks like. So I'm just going to click on sum here. So this is the sum here. This doesn't look like much, but if I actually take this vector by the tail and drag it so that its tail lines up with the tail of the first vector, you can see that the triangle closes. So that corresponds to a sum. So an example would be if a plane is flying in this direction, oriented at the 30. So if a plane is, I'm just going to slide this up a little bit here. So if a plane is flying at 32 degrees, but then the wind is blowing at 73 degrees, the wind is going to carry the plane. So overall, the effective motion of the plane is going to be directed, in this case here, at 53 degrees. But you're not really going to be responsible for adding vectors graphically. This is just to give you a sense of what the addition of vectors look like. But what you are going to have to do, though, is to calculate the addition of vectors algebraically. So let's see how we're going to do that. So I'm just going to move this to the side here. And the way that we're going to double check that these vectors add up graphically, algebraically, is by checking their components. So let's check the components of both of these vectors here. So remember that vector 1, its x component was 8, and vector 2, its x component was 3, and let's check the x component of the sum vector. So if you check the x component of the sum vector, it's 11, so one big square is 5, another big square is 5, and plus 1, that's 11. And let's see how that compares with the x component of the other two vectors. So the sum vector, its x component is 11, and now the x component of vector 1 is 8, and the x component of vector 2 is 3, and 8 plus 3 does give you 11. So if you double check only along the x direction, so this is 1, 2, 3, 4, 5, 6, 7, 8, add 3 more, 9, 10, 11. So whenever you add vectors algebraically, you're always going to add up the x components together individually. Well, what I mean by that is you're going to add x components with x components. And let's check the y component. So the sum vector, its y component is 15. So one big square, two big square, three big squares, so that's 15. So let's double check how this corresponds to the y component of the other two vectors. So vector 1, its y component was 5, and vector 2, its y component was 10. So there, 5 vectors. So let's just count it. So 1, 2, 3, 4, 5. So that's going to be the y component for vector 1. And let's check the y component for vector 2. It's, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And 5 plus 10 gives you 15. So in general, whenever you add vectors together, you're always going to add the x components of the two with x components to get the sum, the total x component, and you're always going to add the y components separately to the of each vector to get the total y component.